Let us learn the course data science, and in unit 1 we have the theoretical contents like introducing the basic concept and usage of data science, and then the phases of the data science process, and in the end we have the data acquisition process like the data gathering the information from different sources, and then about web application programming interface, that is APIs, along with open data sources and web scraping. And then we are supposed to know on the contents of NumPy and Panta. In NumPy, we have to create the list first, and then we have to create a array from the list, from the tuple, and from the dictionary, and then we have to know the concepts related to the array basic operation like joining of two arrays, splitting of two arrays, searching arrays, sorting, and then we have to know the syntax of indexing, slicing, iterating, and copying arrays, and then the array shape manipulation with the identity array I function, and then we are supposed to use the exploration of data using series, exploring data using the data frame, and then re-indexing, drop entries, selecting entries, data alignment, rank, and sort, along with the statistics. So these are the topics we are going to discuss in Unit 1. So how to create an array? So this NumPy is a powerful Python library which are used for numerical computing. So to import NumPy, we have to use the statement import NumPy as NP, and then you can see this array is equal to np.array 42, and then print array. So here the variable name is arr, and here we have the syntax print, no semicolons, nothing is needed. Simply we have to create a scalar array with the single number 42. So here the output it will be a scalar array which has no dimension, no length, it's just one value. So coming to the one dimensional array, as a first step we have to write input numpy as np, then the variable name is arr, that is equal to np.array, and the list which includes 1 2 3 4 and 5, and then if we print arr, we pass a single list, and then the array it has one dimension, and it looks like a row of elements which are commonly used to represent a list of numbers, a vector, a single row of data. So coming to the two-dimensional array, the syntax we are supposed to write is we use double square brackets, and inside the double square brackets you can see the values. So the inner list it will represents a row, and here this array it has two rows and three columns, and these 2D arrays are commonly used for tables of data, matrix, and spreadsheet. And coming to the three-dimensional array, a three-dimensional array is an array of two-dimensional array. The outermost this bracket it group multiple two-dimensional arrays. Each two-dimensional array it will have its rows and columns, and we can imagine it to be a stack of matrix or multiple tables stacked together, and this structure is mostly used with image processing, deep learning, and scientific data. Sample code to create an array from list. So here you can see py underscore list. You have a list containing the values 1 comma 2 comma 3 comma 4 comma 5, and so from this list we can generate an array. We are supposed to use the syntax np.array. So then if we print np underscore array underscore from underscore list, the output you will get as 1 2 3 4 5. So we can generate an array from a Python list. Generate an array from Python tuple. So the first line, as usual, we'll be writing import numpy as npay. Then we have the variable py underscore tuple. Within the brackets, you have the values 1, 2, 3, 4, and 5. And here is a variable np underscore array from tuple. And here you have the syntax np.array py underscore tuple. And if we print this variable, you will get the output as 1, 2, 3, 4, and 5. So by using np.array, we can also create an array from tuple. Slide, we can look into the different ways of creating special array in NumPy using built-in function. As a first step, in all the cases, we are supposed to import NumPy using the statement import NumPy as NP. Then here is an example to create the one-dimensional array of zeros. So here np.0 within the bracket 5, it creates a one-dimensional array with 5 elements and all values are 0. Here you can see the output, and here we can see the decimal points. NumPy create float by default. And then here is a second case of creating a two-dimensional array of ones. For this, we'll be using the syntax np.ones within the brackets 2, 3. That means it creates 2 rows and 3 columns, and the array is filled with ones. So you'll get the output like this. The shape is 2, 3. That means 2 rows and 3 columns. And the next case is creating an array with values from 0 to 9. For this, here you are supposed to use the variable range underscore array that is equal to np.arrange within the bracket 10. That means this np.arrange 10, it generates numbers starting from 0 up to 10, but it will not include the value 10. And so here is a code to create evenly spaced values between 0 and 10. So in this case, we will be using the syntax nb.linspace. We are supposed to have the start value, then we are supposed to have the stop value, and then number of values. This creates, in this case, we have the start value is 0, the stop value is 10, and the spacing value is 5. So this line, it will create 5 evenly spaced values between 0 and 10. So you'll get an output like 0, 2.5, 5, 7.5, and 10. Unlike this arrange this linspace, it will include the ending value and it will divide the intervals evenly. Then here the fifth problem statement is like creating a 2 by 3 array of random integers. Here it will be using the syntax nb.random.rand int 0, 10, and the size of random integers to be generated from 0 to 9, and it is of 2 by 3 array. So here in this case 0 is included, but 10 is excluded. Also use other functions from other libraries to create NumPy array, and here we are importing pandas at pd, and then we can use def is equal to pd.data frame, and you can give the a list of values, and this data frame column, it can be converted to the NumPy array. And if we print this variable np underscore array from pandas, you'll get the output as 1, 2, 3, 4, and 5. NumPy does arithmetic element by element, not like Python list. For example, this Python list, it cannot directly add, but this NumPy array allow mathematical operation directly. That's why NumPy is powerful for data analysis, scientific computing, and machine learning. And here you can see the usage of operators plus and minus. So here the first example, we can add two arrays of same length. So here the operator plus is used. So here what you can see the result is this 1 plus 2 is getting added, 3 plus 4 is getting added, the 5 plus 6 is getting added to 11, and then 7 plus 8 is getting added to 15. And this is called element wise addition. And by using the second method, that is np.array, this plus operator, the same functionality is done here. Both the methods, it gives us the same result. Likewise, we can also do subtraction. The first method we use the minus operator, and in the second method we'll be using np.subtract. So here by using the first method, by using the minus operator, here you can see the subtraction happens element by element. 3 minus 2, that is 1, 9 minus 4 is 5, 27 minus 8 is 19, 81 minus 16 is 65. And by using this operator np.subtract also, we can get the same result. So unlike this Python list, this NumPy arrays, it allows the mathematical operations directly. Addition and subtraction, we can also perform multiplication and division in NumPy arrays. So here is an example. We can also use the operator. Otherwise, you can use the syntax np.multiply. So in this example, as a first step, we'll be importing NumPy as NPy, and then the first array, the values are given as 1, 3, 5, and 7. The second array, the values are given as 2, 4, 6, and 8. And if we use the operator asterisk, you will get the result as 2, 12, 30, and 56, element by element multiplication. Otherwise, we can use this np.multiply. Within the bracket, you can trace first array, comma second array, you will get the same result. Likewise, we can also perform the division. So the first array, the values are 1, 2, and 3, and the second array, the values are 4, 5, and 6. And we can use the division operator. If I divide 1 divided by 4, it is 0.25, and if I divide 2 divided by 5, it is 0.4, and if I divide 3 divided by 6, it is 0.5. This is the first way of doing the division. And we can also use np.divide, comma first array, comma second array. We will get the same result. So we have the greater than operator. So again, these two elements are compared. 1 is greater than 3, that is false, and 2 is greater than 2, that is again a false, and 3 is greater than 1, that is true. And in the third instance, we are using equal. So we are making a comparison. So 1 is equal to 3, again that is false, and 2 is equal to 2, that is true, and 3 is equal to 1, that is again a false. This is how the comparison of entire data set happens with a single line of code, and the resultant you'll have a Boolean results. Again, these codes are the continuation of the element-wise comparison between two arrays. So instead of comparing the entire arrays as a single object, this NumPy compares each corresponding pair of element and returns the new Boolean array. So the code initializes two arrays of the same length, array 1 to be 9, 12, and 21, the array 2 to be 21, 12, and 9. And each function here, that is np.less, it performs the less than operation, and then np dot less equal is there, and then np dot greater is used, and then np dot greater than or equal is used, and then np dot equal is used, and np dot not equal is used. As you know, the output, it will be a Boolean values true or false. And this comparison, it happen index by index. That means the comparison, it happens between the first elements, and then the result is always an array of the same shape containing only true or false values. So these functions are equivalent to the usage of the standard Python operators like less than, greater than, and equal directly on the arrays. Right, how to perform element-wise logical operations on Boolean NumPy arrays. The input arrays are x1 and x2 containing the Boolean values true, false, true in x1 and false, false, true in x2. This NumPy applies these logical gates to each corresponding pair of elements at the same index. np.logical and x1, x2, it returns true only if both the elements are true. So true and false, it will give us the output false, and false and false, it will give the output false, and true and true, it will give the output as true. And np.logical r, it returns true if at least one element is true. So true and true, it will return the output as true, and false and false, it will return the output to be false, and true and true, it will return the output to be true. And this np.logical not flips the value of a single array, that is inversion, and if it is true, the output will be false, and if it is false, the output will be true, and if it is true, the output will be false. These functions are essential for complex filtering. For example, we can use them to find data points that meet multiple conditions at once. For example, to find the values that are greater than 10 and less than 50 in that case.